Hello, good day viewers. Into this tutorial, we are going to see the applications of dimension. I recommended you to check back to my video on I introduced the dimension, how to find the dimension of velocity, how to find dimension of acceleration, pressure, and weight and rest. So today we shall see a different question from that, because this is like a word problem. So the question says a period of oscillation of a simple pendulum depend on the mass of the bulb, meter, measure in meter, and the length of the string L, initial velocity, and what? An acceleration G, and therefore what? Obtain an expression for what? For the period of vibration of a simple pendulum. So like, they said that we're going to what? We're going to express an equation. It's like express, they say that obtain an expression. It is like an equation or formula that we are going to express. But let's see. But what are we looking for? We're looking for the period, which is time. So the t is directly proportional to what? They give us what? The length, which is L, multiplied by what? Initial velocity. And initial velocity, it is what? Initial velocity, it is 0. But we have what? Mass first. We have mass and the length and initial velocity, which is 0, and we have G. So therefore, because of we are looking for it, we have to put this x, this as x, this as what? Y, this as z. What next am I going to do? The next thing is that, sorry, this is the same thing as M, not capital M. The next thing is that I have to say if I say T, it is equals to K, mx alpha y, and G what? G power Z. How did I introduce this K? Because of proportionality. So therefore I know that I will take away of the K, but for now, assuming let's say K is the same thing as 2 pi. K is the same thing as 2 pi. From what? From the experiments. So therefore the T should now be what? Equals to, so I'll put the M, X, L, Y, G, Z. So in dimension, let's recall it. We say mass is the same thing as capital M. Displacement or distance is the same thing as L. So therefore, we said acceleration. We have been given acceleration. What is acceleration? Acceleration is the same thing as change in velocity over time. What is velocity? So I have to say change in velocity. Velocity itself is displacement over time, and therefore divide by this time again, because itself velocity is displacement over time. So this shall now be equals to displacement is measured in L, and therefore time in dimension is the same as T, and the same thing over T. And therefore this shall now be equals to LT to the minus 1, T to the minus 1. Minus 1 is the same thing as T to the minus 2. So now acceleration shall now be what? LT to the minus 2. So L itself, it will give at itself. So therefore the T should now be equals to what? This should now be capital M. Yeah. And therefore power X. L should now be L itself. And therefore G is the same thing as what? There's LT raised to minus what? Minus 2 of what? Of Z. I hope you get this one. Please kindly pause the video and see whether there is a point that you might be lost. The Z itself, the G itself, it is this, and therefore the Z contains all this. So now I will distribute the power of Z in the what? In the bracket. So let me clean the board. The next thing here is that this T should now be equals to, I have M to the power of X. I have L here. So if I distribute, okay, sorry, here there is Y. Sorry for that. So if I distribute this, it shall now be what? I'll have this to Y, and I'll have L to Z. And therefore I'll have what? T to negative 2Z. So the next thing here to do is that I'm looking for the value of x, y, and this. But you all know this is multiplication, this is multiplication. So t shall now be equals to m to the power of x, and I'll have n. You all know that if we have division according to the laws of indices, we're going to subtract. If we have multiplication, we're going to what? Add. So therefore this and this should now be power y and power z. So therefore this L power y and what? This L power z is the same thing as Ly plus z. Don't ask me why. According to the laws of indices. Yes. So the next thing to do is that I have to clean this. And then I'll just insert L to the y plus z. And I have what? T to the negative 2z. Yes. I've done with this point. So therefore, the next thing that I'm going to do is that I will say this t. I will start for, let's start for t. T, I have the value of 1, it is equals to. Here I don't have t, I don't have t, I don't have, okay, I have t, the t which is minus 2z. Let's call this equation 1. So let me do for m. For m, here I have 0 in this because I don't have m. You have to take note. You have to do for each letter. I've done with t because in this equal sign I have t. So I will replace it as 1. And this should now be equals to, I don't have t here, I don't have t here, should now be 0. So therefore here I have t, so I'll just pick the coefficient. So y here, I'm looking for what? M. So for m, here I don't have m, so it should now be 0. Here I have m, so it should now be x. I don't have m, I don't have m, so this should now be equation 2. And then for L. For L also, I didn't have L here, so that should now become 0. So therefore, this should now be, what is the value of L? Value of L, which is y plus z. This should now be what? Equation 3. I have to get up to this point. So, the next thing that you're going to do, this should now be the same, this is the same thing as saying x, it is equals to 0. Yeah. So, what of y? Here y plus z it is equals to 0 is the same thing as saying y plus z it is equals to 0. When I make the y is under the formula, y shall now be equals to negative z. But for now I have to find the value. I have 1, it is equals to, this is the same thing as saying minus 2z it is equals to 1. Because I just picked this first and then I have this equal sign. So I'm looking for z. If I divide both sides by negative 2, negative 2, negative 2 should cast negative, z it is equals to 1, negative 1 over 2. So this is the value of z. And I have to find the value of y. Since I have the value of z, it is equals to negative z. So if the negative made, it will now become 1 over 2 positive. So this is now become the value of y. And therefore, as usual, I know x is the same thing as 0. Yeah, x is the same thing as 0. So what is the next thing to do? The next thing to do is that the board is too small, but we can manage. So I have to just take a look to this equation. Yes, this equation, take a look to this equation. Because it's the equation that I have the value of k. So the value of k should now be included. The next thing is that anything that's the power of 0, I'll substitute this, it will now become 0. Anything that's the power of 0, sorry, is 1. So therefore, no need of footing, because if I times it by this, it will give me the same thing. So what of L? L, it has the value of y. What is the value of y? Which is positive a half. Yes. And therefore, what is the value of G? What is the value of G? Okay, the value of G, It is power of z. The power of z should now be negative 1 over 2. So therefore, the expression should now be t. I hope you're saying it. T, it will be equals to k as what? I say k should now be 2 pi, which is 2 pi. So the L, it is in square root. It is the same thing as saying square root of what? L divided by what? Okay, forget about the divide, but just put L. But you all know this L, root of L is the same thing as L to the half. So I have to say so. Since I have g to the power of negative 1 over 2, so this negative is the same thing as over, and this half is the same thing as g having the square root. So this is the expression. So this is all I have for you for the applications of dimension. Don't forget to subscribe to this YouTube channel for more exciting videos, and please do share to your learning colleagues. Thanks you for watching.